Hello and welcome to this video where I will talk about my text, The Nature of Time. A link to where you can read about it will be posted in the comment section. Yeah, um, this idea is not so much of like a theory or something, it's just more like my view on how time needs to work according to fit the well-known theories of time, such as relativity theory. So, what do we know about time? Yeah, we know that time exists. It's a physical quantity that moves forward all the time. As far as we have observed, at least, time is always moving forward. Okay, but we also know that time does not travel in the same pace all over the place, and not all observers do observe time similar. So, like two observer or two places can move forward in time in different pace, which means that, to make an easy example, like on one place time can move like 1 year, and another place the time moves 1 year and 1 second. That was just arbitrary numbers, but yeah, you get the idea. Like in some place times move faster than other. This will directly result in that the idea of the existence of a timeline is just bullshit, or is a wrong interpretation of time which we have. And it's not so strange that we have it, because the two things which we associate time with is, first, our memories. They are put up in a timeline because in our life we see times as one moment after another. Therefore, timeline seems quite reasonable. And the same thing is with time in the history books, another place where we encounter time. And there also things make sense to put events in a timeline, because it seems like, oh, the antiques were before, I don't know, World War One, which were before, I don't know, the present, and so on. So it makes sense. But physically, thinking of a timeline makes everything much more difficult to think about, especially when you think about like how times really work, and if you try to like cheat time, or like try to bend time, or try to think about like what you can do with time, because then you wrongly can make incorrect assumption about the timeline. And I'm going to talk about the incorrect assumption of how time travel works. In all like science fiction and yeah, and other books and films and so on, timeline always like time travel always assume that there is a timeline, because when someone is traveling in time, they come to a new time. Like, for example, if a person goes back in time, they end up in the past in the exact same constellation as the past were, where all the things were exactly the same as the last time. For example, if I were in a movie and I would go back in time to meet, let's say, Julius Caesar, he would still be in Rome, and he would still do the same thing as he did. That's the idea in movies when you travel back in time. But that is not what happened in real world, because for the first thing, which is very important to remember, is the time, or that all places in the universe has their own perspective of time, or like all part move in their own path towards the future. For example, if we have two celestial bodies here, we have maybe like the Earth and the Moon, or Sun and the Earth, or any other two celestial body objects. They move which has different mass, they would move into the future in different pace. That is a very well-known fact that bigger bodies move slower into the future than smaller objects. And we ain't gonna go into the detail here. There are probably a lot of good videos online to look where they will explain why, or why actually, I'm not sure, like at least explain how Einstein's theory of general relativity explains how this is happening. Yeah, but the idea is still that a smaller body moves into the future faster than a bigger celestial body. So, and this makes that if this proves, actually I would say that this proves that two objects do not have a joint timeline, which means that if one body moves in one direction or somewhere in time, the other body does not care about it. The other body moves in its path into the future regardless of the other object. So let's say that the person standing here on, let's say this is the moon and this is Earth, the person has a time machine which can not just go into the future but also can move into the past. We don't know if this is theoretically possible, but let's assume right now that in some future we will have this. And this person moves into this time machine on moon, and he travels back in time. He travels like 1 year back in time. Another person someone standing on Earth would not move back in time. Earth would actually move forward in time because Earth does not have the same timeline or the same path in time as moon. So Earth will not move backward. Earth will move forward. So when he have moved 1 year backwards in time, Earth would move 1 year, or it will move forward maybe 1 year if his time machine moves 1 second backward as Earth moves 1 second forward. It's a good question. It depends on how this time machine would work. But let's assume that. So let's assume that as he goes 1 year back into the past, Earth is moving 1 year into the future, which means that this person will not be the same person back 1 year back. This person what would really happen, this person will go back in the past. But we on Earth, we would move forward, which means that he will end up in the future. In our future, in our perspective, he will end up in the future. So what happened is that he moved into time machine, and in his perspective, he was moving backwards. But in our perspective, he was moving into the future. And this is the biggest difference between time machines in real life, at least if they need to work according to general relativity, and time machines in movies and books and such. So in the real world, if you go back in time, you will end up in the future. And why? Because every position on the universe has its own path towards the future. So even if he was standing on Earth, going into a time machine on Earth, he would not go into the past. He will go into his past, but he will not go into my past because I'm not standing inside the time machine. So I would move into the future, and he would move backward in his position. But when he switch off the time machine and goes out of it again, I would be in the future, and I would say, "Oh, where have you been for a year?" And he would not go back into the past, because if he wants me to go into the past, he will not step into the time machine. Then I need to step into the time machine. So of course you can imagine like by that this guy wants to go into the past, that he goes to the moon, then put the entire Earth into a time machine, so Earth goes back in time. That is actually theoretically possible with this theory. So that then, after Earth had gone back 1 year, it will seem for him that he had moved, or it will look for us that he had moved 1 year, that he would move back in time. Because we moved back in time, but he stayed outside. But then we come to a new number of problems that the next time we go, like for example, if this is 2017 as today, and we go back 1 year until 2016, it will not be sure that that 2016 will be the same as the last time we were there, because there is no law of physics which forces a place to be similar on the same time it's there. Okay, to explain this. If we go forward in time, all chemical reaction happen, all the quantum mechanical things happen, and all that thing. There is, as far as I know, and as far as I have seen anyone else knowing, there is no physical law forcing that if you reverse the process by moving time backwards, everything will need to happen backwards. For example, I definitely believe that quantum mechanical reaction are true random, and it seems very likely for quantum mechanic interaction to be true randomly. And if they are true random, they will not by force then go the exact way backwards. So there is no guarantee that the past will look the same the second time. So example, for if we put Earth into time machine and go back within time, because we say, oh, we want to stop the Second World War because it was so horrible, it's not sure that it will be the same next time around we came into the 1930s and 1940s, because the same reaction is not necessarily to happen. It's also the big problem is that the entire Earth is that during the time a lot of particles has left Earth. These particles will probably not fall back. Like if a photon leaves Earth and scatters out in universe, this photon over here somewhere, it will not go back because it was Earth going back. So this photon will not land backward where it came from. But at the same time, a new photon from the sun will hit Earth, even though Earth is moving backwards, because the photon moves in its path into the future. So on the border of Earth, in this time machine, it will not happen the same time as the last time. So for one thing, for example, Earth gets heavier and heavier every year due to that material from space fall down to Earth. This will happen even though we go backward in time, because the rest of the universe will still go forward. So a lot of things will still fall on. So if we go backwards in time, we will still get heavier and heavier. Yeah, that's a little bit like thinking. If it's not clear, you can download text for free, of course, and try to read up on it. If something is unclear, please let me know, and I will try to make it. I will try to make a new video. Thank you for watching.